Hopscotch was also intended to be one of our simpler problems. You're given a grid of numbers from 1 to k, and you want to, being childish, you want to play hopscotch on them. So you want to start at any number, any tile numbered 1, you want to hop to some tile number 2, some tile number 3, 4, 5, and I only go through 5 here, but up through whatever k is. We used the Manhattan distance, which is the absolute value of the difference in the x's plus the difference in the y's. We used that because we wanted the output to be solely integers. We didn't want you to have to go to real numbers and then have, a tolerance. We wanted to keep it as simple as possible, and that's why the judges chose to use the Manhattan distance as opposed to the Euclidean distance. And the problem is really very simple. It can be solved by many different dynamic programming techniques. The technique that we were targeting was Dijkstra, a simple Dijkstra shortest path algorithm, where you keep a priority queue of what tile you're on and how far you've gone so far, and then look through a tile with the next number, whatever that distance is, create the new state, put that on the priority queue. I think that anybody in this contest is familiar with Dijkstra. There are other dynamic programming solutions which might be similar, but Dijkstra is really what we were targeting with this problem. There is one thing that you can do to speed it up a little, and what we learned is that you really don't need to do this. We would accept solutions that didn't do this. But if you really wanted to speed it up, you could do a pass through the array at the very beginning and keep a list for every number k of which squares in the grid had that value. So for instance, in this grid, array sub 1 would have the indices of these squares in it, and array sub 2 would have the indices of these squares in it. And when you do that, at every step of the Dijkstra, if you're at a 2, you need to go to to a tile with 3. You don't have to look through the entire array. All you have to do is look through the list of all the squares that have an index of 3. But as I said, that's a very nice, convenient thing to speed it up a little bit. But we found that if we didn't do that, our code ran in an appropriate amount of time, so it's not necessary.